NASA says its Voyager One probe, the most distant human-made object in the universe, is sending usable information to Earth again.
In 1977, Voyager One left Earth carrying humanity's greatest message to the stars. For decades, its faint signal traveled back across billions of miles. But recently, NASA confirmed a new transmission, one that wasn't supposed to happen. The signal contained anomalies so strange, even veteran scientists admitted they were terrified. This is the disturbing truth of Voyager One's final message. The launch of humanity's messenger. The story of Voyager One begins on a blazing Florida afternoon when a white rocket carried a strange dish-shaped robot into the unknown. On September 5, 1977, it left Cape Canaveral's Launch Complex 41, strapped to a Titan booster stacked in 3 stages. The launch time was clocked down to the second 12:56 and 1 second UTC. But Voyager's destination wasn't a planet. It was everything beyond them. The probe itself looked more like a tool than a trophy. Fully fueled, it weighed about 1,592 pounds, its body a 10-sided box with a 12-foot antenna mounted at the front. That dish was its voice, built to beam faint signals all the way back to Earth. It didn't rely on modern reaction wheels to keep steady. Instead, it pulsed small thrusters in a 3-axis system that gently nudged it into balance, always keeping the dish locked on home. Power came from 3 nuclear batteries, radioisotope thermoelectric generators, each pushing about 158 watts at launch. That steady nuclear trickle meant Voyager could survive where sunlight was too weak for solar panels. For steering, engineers gave it 16 tiny hydrazine thrusters, each one producing about 1/5 of a pound of force. That's barely the weight of a stick of butter, but in the emptiness of space, it was enough to swing the craft with surgeon-like precision. Hydrazine breaks down over a catalyst into hot gas, and quick puffs from those jets cleaned up any wobble. Bigger thrusters corrected the main flight path, while the system was designed so backups could take over if the primaries wore out. Voyager One was actually the second to launch, but its route was designed to beat its twin. Scientists had discovered a rare lineup of the outer planets that happens only about once every 175 years. The trick was to use gravity-assist slingshot maneuvers to leap from world to world. Voyager 2 would take the longer path, visiting all 4 giants. Voyager 1 was aimed for speed, skipping the chance to see Uranus or Neptune in order to zero in on Saturn. Phase 1 was clear: hit Jupiter in early 1979, then reach Saturn in late 1980, brushing past their moons and rings while sending back the sharpest pictures ever seen. And right on cue, Voyager arrived at Jupiter on March 5, 1979, and at Saturn on November 12, 1980. The images stunned the world. The great red spot boiling like a hurricane the size of Earth, rings etched in knife-thin detail, and moons that turned out to be active worlds, not dead rocks. But Voyager's mission had a second chapter. Once Saturn was done, keep going. The plan literally charted a path labeled After Saturn. That plan hinged on a gamble. Engineers wanted a close flyby of Titan, Saturn's largest moon, cloaked in a thick, mysterious atmosphere. To reach it, Voyager had to thread a precise corridor. Do it right, and Titan's pull would whip the craft over Saturn's south pole and out of the planetary plane entirely. That one decision cut off any shot at Uranus or Neptune. But it gave Voyager something no probe had ever earned: the fastest escape track out of the solar system, aimed straight at interstellar space. Even before it reached Jupiter, Voyager had already sent home a photograph that changed how people saw Earth. Just 2 weeks after launch, from more than 7 million miles away, It turned its cameras back and captured Earth and the Moon together in one frame for the first time. Earth was a crescent with the Pacific Ocean and Asia visible under the clouds, while the Moon glowed like a tiny bead of light above it. There was one more piece of cargo, strapped to the side with equal parts science and hope. A 12-inch gold-plated record. Carl Sagan and a small team filled it with greetings, sounds, and music. A cosmic message in a bottle, complete with instructions for whoever or whatever might find it. The bottle is still sealed in Voyager's skin, waiting. Back in 1977, most people thought about the postcards from Jupiter and Saturn, but no one imagined that decades later it would be sending back signals that defied explanation. Crossing into interstellar space. Interstellar space begins where the sun's breath finally runs out. That breath is the solar wind, a constant flow of charged gas blowing outward in every direction. For billions of miles it keeps going, but eventually it slams into the thin gas drifting between the stars. The spot where the sun loses that battle is called the heliopause. On August 25, 2012, Voyager One crossed it at a distance of about 121 astronomical units from the Sun, roughly 11.3 billion miles. In that instant, it became the first human-made object to leave the Sun's bubble and enter interstellar space. The world didn't hear about it right away. NASA held off for almost a year, double-checking every reading, because what Voyager encountered out there wasn't clean or simple. It was something new. The easiest way to prove such a crossing would have been with a plasma spectrometer. Basically, a cup that scoops up the solar wind and tells you how fast and how dense it is. But Voyager's plasma cup had died back in 1980. That could have left the team blind. Instead, they turned to a backup instrument that didn't sip gas, but listened to it. The plasma wave subsystem. Ionized gas, or plasma, can vibrate like a bell when disturbed, sending out faint songs at specific pitches. If you know the pitch, you know how dense the plasma is around you. Inside the sun's bubble, it should be thin. Outside, it should be dozens of times denser. The catch was, they needed a strong enough event to make that local plasma ring out loud. That event finally came. On April 9, 2013, Voyager's instruments picked up a clear tone around 2.6 kilohertz. That sound meant the local plasma had an electron density of about 0.08 particles per cubic centimeter, right in the expected range for interstellar space, and far thicker than the outer reaches of the heliosphere. Even better, Voyager had already recorded 2 earlier plasma songs. One in late 2012, and another in the spring of 2013, both triggered by shock waves from solar eruptions pushing outward. These ghostly tones were the smoking gun. Voyager was no longer in the solar wind. It was swimming in interstellar plasma. On September 12, 2013, NASA finally announced the crossing had taken place the summer before. The plasma music grabbed headlines, but the first hints had actually come from Voyager's particle detectors. On the day of the crossing, August 25, 2012, the spacecraft was parked about 121.7 astronomical units from the Sun, more than 11 billion miles out, when the radiation readings flipped dramatically. The low-energy particles, the ones born inside the heliosphere, collapsed to nearly nothing. In some cases, their levels dropped by factors of 300 to 500 in just weeks. At the same time, the higher-energy galactic cosmic rays from outside spiked. Electrons surged by 30 to 50% in a single day. This was the textbook fingerprint of the boundary. The Sun's particles vanished. The galaxy's particles came flooding in. The biggest surprise, though, came from the magnetic field. Scientists had expected the field's direction to swing dramatically once Voyager left the heliosphere, like stepping into a new current flowing at an angle. Instead, the strength of the field jumped, but its direction barely shifted. In late 2012, the team even described what they called a magnetic highway, a region where magnetic lines seemed to guide particles out, yet still lined up with the inner direction. That unexpected detail kicked off a debate. Maybe the edge of the bubble is tangled, or maybe the galactic field drapes over our sun's bubble in a way we didn't imagine. Either way, the absence of a sharp twist didn't erase the evidence. It just showed the boundary is far more complicated than the tidy diagrams we'd drawn in textbooks. From that moment, Voyager One was no longer just a planetary probe. It was an interstellar craft, still close enough to feel faint traces of the sun, but undeniably inside a new sea. Now, here's the part that really caught scientists' eyes. The readings didn't just confirm the crossing. They also revealed disturbing anomalies, patterns no one fully understood. The signal that shouldn't exist. In mid-November of 2023, the most distant machine ever built by human hands started talking in a way no one could understand. Voyager One was still alive, more than 15 billion miles from home. But the stream of ones and zeros it sent back to Earth no longer made sense. NASA's Deep Space Network was picking up a strong signal, but when the engineers tried to decode it, nothing came out. No temperatures, no voltages, no science data. It was like answering a phone call and hearing only a steady tone. To some, that precision felt uncanny, as if the probe was reacting to something rather than simply failing. After weeks of round-the-clock checks, the team traced the trouble to one of the spacecraft's oldest computers, the Flight Data Subsystem, or FDS. If Voyager were an office, the FDS would be the mailroom. Every bit of information about the spacecraft's health and its science instruments passed through there first. The FDS would collect it, pack it into neat digital frames, and then hand those frames to another box, the Telemetry Modulation Unit. The TMU's job was to stamp that data onto a radio signal and shoot it back to Earth. If the mailroom broke, the radio could sound fine while the content turned into gibberish. In early December, after weeks of puzzling, engineers found the first clear clue. The TMU was locked into a repeating cycle of ones and zeros, a dead giveaway that it was getting bad data frames from the FDS. The radio was fine. The problem was deep inside the mailroom. That diagnosis gave them the next step: make the FDS reveal what was inside its memory. In March of 2024, controllers sent up a tiny sequence of commands, a digital poke telling the FDS to dump out a snapshot of its memory. The process was agonizingly slow. A command took 22.5 hours to reach Voyager, and the reply took another 22.5 hours to come back. Every single move took days. When the memory dump finally arrived, the mystery sharpened. About 3% of the FDS memory had gone bad. A single chip, responsible for storing part of the code and its variables, had failed. It might have simply worn out after 46 years in space. Or maybe it was fried by a stray cosmic ray. Either way, the damage meant the FDS could no longer build proper frames, so the TMU kept transmitting the same empty skeleton again and again. That was when the story shifted from diagnosis to surgery. Voyager's computers are tiny by today's standards. The FDS had about 70 kilobytes of memory in total, smaller than a single photo on your phone. There was no backup waiting. To keep the system running, engineers had to move code into tiny slivers of unused space scattered around the rest of the memory. Then rewrite the pointers so everything still lined up. Imagine rewriting a book where 3 pages are missing, and the only way to fix it is by scattering bits of those chapters throughout the rest of the novel while keeping the story readable. That's the level of detail required, except done with code written in the 1970s. On April 22, 2024, the first breakthrough came. For the first time in 5 months, Voyager One sent back clean engineering data. Temperatures, voltages, the vital signs that told controllers the spacecraft was still stable. The radio had never failed, but now the content was finally making sense again. NASA confirmed the achievement that day, but they also made it clear the real goal was to bring back the science. That part was harder. The FDS needed to be taught, line by line, how to collect and package instrument data without ever touching the corrupted memory. That meant more careful commands, more rearranging of code, and more long waits as signals crawled across interstellar space. On May 22nd, NASA announced another step forward. 2 of the 4 active science instruments were back online. The plasma wave subsystem and the magnetometer were once again returning fresh numbers. The other 2 instruments had to wait their turn for recalibration. Then, 3 weeks later, came the payoff. On June 13th, NASA confirmed that all 4 science instruments were once again returning usable data. For nearly 7 months, Voyager had been speaking in structured nonsense, repeating the same empty blocks of information over and over. By summer of 2024, the gibberish was gone. The data made sense again. Suzanne "Susie" Dodd, Voyager's project manager at JPL, admitted this was the most serious challenge the team had faced on her watch. Although NASA confirmed it wasn't a ghostly signal, but a computer failure they had managed to fix from billions of miles away, another thought lingered in the background. What if the probe wasn't just malfunctioning? What if those strange repeating patterns had been triggered by something outside? That question unsettled people most. The disturbing plasma wave anomalies. Out beyond the sun's protective bubble, Voyager One began to pick up something the inner solar system had never prepared us for. Its plasma wave subsystem, basically a sensitive radio ear that detects faint electric ripples in space, first caught quick bursts whenever shock waves from the sun plowed into interstellar gas. But in 2017, the pattern changed. The sharp, occasional bursts gave way to a steady, faint, continuous tone. That eerie hum never shut off. It was the sound of the very local interstellar medium, the VLISM, resonating around the spacecraft, letting scientists track the density of nearby electrons day after day as Voyager drifted farther outward. The numbers are where the surprise begins. Near the edge of the sun's bubble, space is incredibly thin, just a couple thousandths of an electron in every cubic centimeter. Cross into the interstellar medium, and suddenly it's tens of times denser. Using the pitch of those plasma waves, Voyager's team measured densities ranging from about 0.04 up to roughly 1/10 of a particle in each cubic centimeter of space, along the paths of both Voyager One and, later, Voyager 2. That leap, about 20 to 50 times denser, perfectly matched what scientists predicted interstellar space should look like. But the way those numbers shifted was the real shock. A study in 2021, led by Stella Ocker, with Don Gurnett and Bill Kurth, showed the new hum provided nearly continuous readings across 10 astronomical units of travel. Each sample was spaced only around 0.03 of an EU apart, giving the scientists a map with incredibly fine detail. Instead of a calm, uniform ocean of gas, The VLISM looked messy, lumpy, and constantly changing. On scales ranging from fractions of an astronomical unit to many astronomical units, Voyager was recording what looked like interstellar turbulence, the chaotic motion of the gas between stars. So what's making this endless hum? Two ideas stand out. One possibility is that it's the natural ringing of electrons in the plasma, what scientists call thermally excited plasma oscillations. Another is that it's quasi-thermal noise, a kind of background hiss that happens when dense plasma shakes the spacecraft's antenna. But the surprises didn't stop with plasma. Some of the anomalies began showing up inside Voyager itself. The telemetry glitch that terrified NASA. In May of 2022, Voyager One suddenly started reporting nonsense about itself. The spacecraft's attitude articulation and control system, the part that keeps it pointed in the right direction, began sending back status messages that didn't make sense. But here's the strange part. Nothing else was wrong. The giant 12-foot antenna was still locked perfectly on Earth. Commands from the Deep Space Network were being received without a hitch. The radio signal was strong and clear. That contradiction rattled the mission team. It was as if the pilot of a ship were babbling incoherently while somehow steering in a straight line. The box at the center of the drama is called the AACS for short. Its job is simple to explain but brutal to execute. Fire tiny puffs of hydrazine fuel through thrusters so the spacecraft never drifts even a fraction of a degree off course. At more than 14 billion miles away, the margin for error is razor thin. If the antenna slips even slightly, the signal to Earth can vanish. But in 2022, while the AACS kept firing correctly, the data it sent back about itself was gibberish. NASA put it bluntly. The spacecraft was operating normally, but the control system was telling lies about its own health. Some engineers even admitted they couldn't explain why the signal itself was holding so steady through the chaos, almost as if something unseen was keeping that lifeline alive. That contradiction set off weeks of detective work. Engineers finally uncovered a subtle, almost absurd cause. The AACS had started routing its data through a computer that had been shut down years earlier. That detour garbled the numbers before they ever reached the radio. The antenna never moved, only the reporting path had gone wrong. The fix was simple on paper, but complex in practice. Send a command instructing the AACS to bypass the dead computer and use the normal channel again. On August 30th, 2022, NASA confirmed the patch worked. The readings made sense again. The ship hadn't been sick. It had been whispering through the corpse of an old computer. What made this whole episode so uncanny was how steady the signal stayed through the scare. By that point, Voyager's nuclear batteries had been fading for decades. They lose around 4 watts of power every single year. To keep the mission alive, engineers have spent years turning off heaters and non-essential systems, funneling every watt they can into the radio, the AACS, and a handful of science instruments. Even with that constant drain, the radio beam never wavered, while the AACS messages turned into word salad. To outsiders, it seemed impossible. In reality, it was the product of ruthless, meticulous power management on the ground. And then there's the part that feels almost like science fiction. Backup thrusters that had been dormant for nearly 4 decades. In late 2017, the mission team reached for the trajectory correction maneuver, thrusters, small engines designed to steer the spacecraft during planetary flybys. They hadn't fired since the Saturn encounter back in 1980. With careful commands, engineers lit them up. To their amazement, the thrusters worked. By 2018, Those ancient TCM thrusters were sharing the load with the attitude control system, giving Voyager a second set of muscles to hold its aim. That miracle of old hardware is one of the big reasons the 2022 scare never escalated into a blackout. The golden record and the fear of a reply. As we pointed out earlier, Voyager One carries more than instruments and antennas. Bolted to its body is a 12-inch gold-plated copper record that carries a snapshot of who we are. It holds greetings in 55 languages, the sounds of Earth, about an hour and a half of music, and more than 100 carefully chosen images, everything from diagrams of DNA's double helix to outlines of human biology. The committee behind it was led by Carl Sagan, who worked with artists, scientists, and cultural experts to weave a message that felt both personal and universal. Even President Jimmy Carter and UN Secretary-General Kurt Waldheim added written notes, sealed in for the ride. The idea was bold. If someone out there ever stumbled on this tiny craft in the dark, they'd be given a fair shot at understanding who sent it. Even the record's cover is part of the message. The metal jacket is etched with diagrams that show how to play it, complete with a stylus drawing that indicates the 3.6-second rotation period, instructions to play it from the outside inward, and a pulsar map pointing back to the sun. In other words, it's not just music and pictures, it's a cosmic return address carved into metal, a way of saying, here we are. Open the grooves, and you'd hear a global mixtape of Earth itself. Thunder, surf, a baby's cry, laughter, and whale song. Then the music begins. Bach, Beethoven, and Chuck Berry, sitting alongside Beninese percussion, Mbuti songs from the Ituri forest, and Javanese gamelan. The greetings begin with Akkadian, an ancient language of Sumer, and end with Wu, a modern Chinese dialect. The images are just as deliberate. The building blocks of chemistry, a page of mathematical units, silhouettes of a human couple, photos of food and landscapes, and those unmistakable diagrams of DNA. Every piece was chosen so it could stand on its own, even if the finder had no shared language with us at all. And yet, tucked behind this gesture of hope is a lingering unease. Decades later, after Voyager had already survived countless technical scares and started acting strangely at the very edge of interstellar space, some scientists and science communicators couldn't help but raise a provocative question. What if any odd behavior from the probe were ever mistaken as a kind of reply? Beneath those conversations sits an even deeper fear that by carrying such a clear beacon, Voyager may already have attracted attention somewhere out in interstellar space. Officially, NASA has never endorsed that idea, and the mission is firmly described in practical, down-to-earth terms. But outside the official reports in lectures, essays, and debates, the thought keeps surfacing, if only as a way to explore the implications. After all, the Golden Record was built as a beacon. It literally explains how to decode itself, and it literally shows how to find the place it came from. That is both its brilliance and its risk. It's here that broader voices in the scientific community urge caution. Stephen Hawking warned against announcing ourselves too loudly, pointing out that when one civilization stumbles across another in human history, the weaker side rarely benefits. That's not an indictment of Voyager, it's a reminder that messages in bottles don't always float back the way you expect. The Golden Record's hope is timeless, but so is the fear of being found by the wrong audience. And then came the most disturbing detail of all: the strange frequency shift. Engineers have a saying, "You live and die by the carrier signal." That's the steady heartbeat of a spacecraft, the part that tells you the link is still alive. Every time NASA's Deep Space Network points one of its giant antennas at Voyager, the process is the same. A dish on Earth sends out a tone a little over 7 gigahertz. Voyager locks onto that tone and answers back with its own reply near 8 gigahertz. On the ground, computers strip away everything that can shift the signal: Earth's rotation, Earth's orbit, the spacecraft's own motion, and even the weather in space. What's left is called the residual. And normally that residual is boring, exactly what engineers want. It's just a whisper that says the spacecraft is out there, steady and predictable. But then came the moment that broke that calm. Voyager's carrier didn't look like the quiet, flat line it should have been. Instead, it carried a strange wobble, a drift that refused to behave. Engineers checked the usual suspects. Cosmic rays, those flip random bits in electronics. But they don't create a steady rhythm. Plasma in space, that can blur or scatter a signal, but it acts like messy weather, not a ticking clock. Yet even after all the normal noise was removed, something stayed behind a slim, repeating trace etched into the signal, like teeth on a comb. That's when the whispers began. A few scientists noticed that the leftover pattern looked structured, almost like the skeleton of an encoded transmission. Even when you can't decode a message, data systems often leave behind regular ticks, evenly spaced markers, little footsteps of order. And here, after every correction, that rhythm remained. Now, it's important to stress this. NASA has never said Voyager is sending a coded signal. But for the engineers watching, the line between random noise and something intentional suddenly felt thinner than ever. The terrifying legacy. Voyager One was supposed to die quietly. On paper, it was only meant to last 5 years, just long enough to dart past Jupiter and Saturn before fading into silence as its nuclear batteries ran down. But the little spacecraft refused to quit. Year after year, it kept phoning home. And in the process, it forced us to rewrite how we think about the very edge of our solar system. For decades, scientists pictured the sun's bubble, what we call the heliosphere, as a neat boundary, like a balloon inflated against the darkness. Voyager's data shattered that image. Even after Voyager crossed that frontier, it picked up something no one expected. A faint, steady plasma tone. It was the interstellar medium itself, the thin gas between the stars humming all around the spacecraft. That eerie, unbroken note was proof that space beyond our bubble isn't silent or still. It's alive. It's moving. Keeping Voyager alive this long has taken engineering discipline on a knife edge. To stretch the mission, engineers have spent decades shutting down heaters, switching off instruments, and rerouting power so the essentials can stay on. By 2025, the team made the hardest cuts, yet retiring some instruments so that a handful of champions could keep listening from more than 15 billion miles away. Voyager One is expected to rely mostly on its magnetometer and plasma wave ear. Voyager 2 is following the same survival script. If the math works out, at least one instrument could still be gathering data into the next decade. But numbers on a chart don't capture the whole story. Even as engineers carefully ration power, Voyager has been sending back signals that don't always add up, odd behaviors that defy quick explanations. And when you place those quirks next to the noisy, unsettled physics Voyager has uncovered at the edge of the heliosphere, the picture grows unsettling. This could be what it looks like when we brush against laws of nature. We don't yet understand patterns that only appear where our bubble scrapes the galaxy beyond. Or maybe, just maybe, it's the trace of something stranger still, a presence waiting outside the solar system that doesn't fit any model we know. Voyager One was meant to be our messenger to the stars. But what it's sending back now may be a warning humanity was never meant to hear. Thanks for watching. Now check out the videos popping up on screen for more unbelievable stories.